Hi, this is Dan the author, and we're back to look at Unit 11, Structural Drawings. In this unit, you will learn how to identify different types of structural construction systems, recognize various types of concrete floor systems, understand concrete reinforcing notation, recognize reinforcing steel on prints, read beam and column schedules, and identify various structural steel members. In Unit 10, we discussed foundation drawings. Now we are discussing the above the foundation structural system prints. Almost all large commercial and industrial buildings are constructed above the foundations around the framework of reinforced concrete and/or structural steel. It is also used for large residences and condominiums. In this unit, we will look at the above-grade structural systems. Concrete. There is cast-in-place concrete, which is concrete cast at the construction site. The carpenters build the formwork to hold the concrete configuration. The ironworkers install reinforcing steel. The laborers place freshly mixed concrete. The concrete hardens by hydration and matures to a minimum specified PSI strength. Then the forms are removed and the concrete configuration stays in place. Precast concrete is concrete that is factory cast and pre-stressed, which means the cables in the concrete are stressed prior to casting the concrete. When the concrete hardens, the cables are released to put the concrete casting into compression. Remember, concrete is much stronger in compression than tension. The concrete also could be post-stressed or also called post-tensioning. This is concrete that is cast and hardens, and then the cables are stressed, putting the concrete into compression. After the concrete has reached its design strength, it is transported to the job site and set into place. Architectural concrete is concrete exposed to view to obtain a desired architectural appearance, used both inside and outside of a structure. An example would be the Rock and Roll Hall of Fame in Cleveland, using all-white concrete designed by I.M. Pei, and the Rosenthal Contemporary Art Museum designed by Zaha Hadid. Note the columns and the urban carpet wall are cast in place, while precast was used on the upper portions of the structure to enclose the building. And here in the same museum, from the inside looking down the urban carpet wall. Architectural concrete can be both decorative and structural. For more information regarding concrete, visit the American Concrete Institute at www.concrete.org. Structural floor systems. The first is one-way slab system. The one-way slab system is constructed with main reinforcing steel spanning in one direction, as seen here in this parking garage floor. A two-way slab system is a slab system that is constructed with main reinforcing steel spanning in two directions, like seen above in this flat slab supported by columns, and this waffle slab outside this library entrance. Steel reinforcement is commonly called rebar. Rebar is used in all types of concrete structural systems. The rebar comes either plain or deformed bars. Most common is deformed bars. The deformed bars have a better bond between the concrete and reinforcing steel, providing improved load carrying capacity and tensile strength to the concrete. Rebar comes in a variety of grades of steel. Grade 40, 50, and 60 KSI tensile strength are typical. KSI stands for kips per square inch, and kips stands for 1,000 pounds of force. The higher the KSI, the more tensile strength the rebar has. There is a number on the rebar indicating the size, sometimes in metric, and all rebar will have a mill mark identifying the producer. For more information on reinforcing steel, visit the Concrete Reinforcing Steel Institute, CRSI, at www.crsi.org. Deformed bars come in 11 different sizes, number 3s to number 18s. The bar number indicates the diameter in eighths of an inch. A number 4 bar would be 1/2 inch, and a number 8 bar would be 1 inch in diameter. The nomenclature for reinforcing steel on drawings are specified by bar size, length when needed, bar on center spacing, and location top or bottom when needed. For example, number 4 at 12 inches on center each way. Here is an example of a concrete beam and joist framing plan and what it would look like when built. The beams are identified with beam marks that refer to a schedule. The same goes for the concrete joists. The beam schedule will indicate the beam size, the rebar size, the spacing for both top and bottom bars, and stirrup requirements. There are many kinds of schedules used in structural concrete, like post-tensioning and column schedules. Using the Cincinnati Manor drawings included in your large prints, let's look at some more concrete prints. Please feel free to pause the video and get the drawings out. Most structural drawings start with a notes page, specifically providing general notes related to the project for easy reference, as seen here in the concrete and reinforcing steel notes. And here I included the foundation plan because all structural prints start with a foundation plan. See Unit 10 Foundation Prints for more information. Here is the concrete framing plan for garage level P3. This is where the section cuts are made like section 3 S301, along with more sections as you work your way around the building. The plan is marked with beam and slab reinforcing numbers, referencing a schedule on the lower portion of sheet S103 for the slab and sheet S505 for the beams. Now using the post-tension beam schedule, let's look at beam B1. First, we see the beam dimensions, 20 by 36 inches deep. The schedule refers to a beam type 1, which is referencing the beam diagrams on sheet S504. Here is a PT beam type 1 beam diagram. The FE refers to the force that will be applied to the PT cables when the concrete reaches its specified strength. The A, B, and C refer to the location of the cables and drape. The TA, TB, and TC refers to the reinforcing steel at the top of the beam, and the BA, BB, BC, and BD refer to the reinforcing steel at the bottom of the beam. You would use these beam diagrams to make the project estimate, shop drawings, and construct the structure. These are the remainder of the post-tensioning beam diagrams that refer back to the concrete framing plans. Using figure 11-13 from the book as an example of a parking garage slab deck with reinforcing, first note the plywood, which is the bottom side of the slab, and the beam forms. Then the beam reinforcing steel, and both slab and beam post-tensioning cables indicated in blue. The green on the reinforcing steel is an epoxy coating to assist this parking garage reinforcing steel to resist salts that might migrate into the concrete. The reinforcing steel is held in place by chairs and bolsters. Let's look at the wall rebar and how to read the nomenclature. This is a 8-inch wall reinforced with number 4s at 12 inches on center each way. That means number 4 bars, 1/2 inch, are placed vertically 12 inches on center and horizontally 12 inches on center. Note the waterproofing at the keyway. This would have to be looked up in the general notes or specifications. Also note the embedded plate for the structural steel divider beam to be field welded later. Let's look at the alternate pilaster detail 6 to show how the engineer is creating a place for the concrete to shrink and possibly crack. First, note the 3/4 inch chamfer on both sides, which is thinning of the wall, along with stopping the main wall reinforcing from continuing through this area. By doing these two things, the engineer has created a weak point in the concrete, and if the concrete shrinks enough, the wall would be forced to crack here. Thus the reason for adding the water stop. Here are some additional framing plan examples. Note here the reinforcing is shown on the plan. For example, number 4s at 12 inches on center, top, by 9 foot 0 inches long. Or over at the cantilever edge, number 4s at 12 by 4 foot 6 inches with a hook located at the top. I think this would be an easier plan to read. The 4th floor framing plan. Note the floor thickness is noted in a note, and the bottom of reinforcement is noted to be number 4s at 12 inches on center each way, unless otherwise noted. And finally, here is a hospital foundation and floor framing plan for a very complicated structure. On the foundation, the column footings are referenced to a schedule. Section cuts are referenced to other sheets. And on the elevated portion of the structure, the beam and joist marks are all referring to a schedule for additional information. Structural steel shapes. As we discussed in Unit 7 materials, structural steel, it is equally as common as concrete in construction above foundation structures. We will not review the structural steel shapes again here. For more information regarding structural steel, visit American Institute of Steel Construction at www.aisc.org. Open web steel joist. Floor and roof structures are commonly supported by open web steel joist, more commonly called bar joists. Typical bar joist classifications are K-series that are considered light commercial, 10 to 30 inches deep with spans up to 60 feet. LH series are long span, 18 to 48 inches deep with spans up to 96 feet, and DLS series are deep long span, 52 to 120 inches deep, with the greatest spans up to 240 feet. For more information on steel joist, visit the Steel Joist Institute at www.steeljoists.org. So let's look at a K-series joist. What does the 12K3 mean? The 12 is the depth of the joist. The K is the series we discussed earlier, and the 3 is the load class, which refers to the size of the joist cord webbing. A 12K3 can span 12 to 24 feet with a load carrying capacity from 550 pounds to 101 pounds per lineal foot. Note, it lessens as the span increases. Now let's take a look at sizing a bar joist using the same Volcraft load chart. Note, all bar joist manufacturers will have load charts for their joist systems. The chart shows the allowable loads for different K-series joist sizes and spans, 8K1 to 16K9 on this page. In example 1, how much weight can a 14K1 spanning 15 feet carry? The answer is go down to 15 feet, then scroll over to the maximum load, 511 pounds per lineal foot. Example 2. Or let's say we have a span of 21 feet and the joists are set at 4 foot on center. The total load of 100 pounds per square foot, which would be 400 pounds per lineal foot, transferred to each bar joist. The option would be a 14K6 allowing 475 pounds per lineal foot, or a 16K4 allowing 447 pounds per lineal foot. The difference being one is 14 inches deep and the other is 16 inches deep. Please note, do not try to engineer bar joist systems unless you are a licensed engineer. Here are some examples of bar joist details. First, for a concrete floor and roof deck. Continuing to use the Cincinnati Manor prints included in your set of drawings, let's look at the structural framing plan for the office level second floor. First note, there are notes in the top right-hand corner that reference back to other sheets, some of which are not included in this set. More on that in a few minutes. Zooming in, we see W30 by 108, a W21 by 50 perimeter beams, a 30 by 90 and W21 by 44 interior beams. The additional nomenclature with the beam size marks is another common question. What does the number inside the parentheses and these other letters refer to? Well, those notes that are in the upper right-hand corner of each framing plan refer back to sheet S004. Sheet 004 is not included with the study set. I have included it here from the original set of drawings. So the figures after the beam that are in the parentheses is the number of studs welded to the beam. The V equals vertical end reaction in kips, and the C equals the camber of the beam in inches. And as we have seen on other sheets, there are detailed section cuts referenced to other sheets in the set, like section 1 S321, that shows a typical slab edge detail. This section mark indicates UNO. UNO means unless otherwise noted. So this detail would apply everywhere a detail is not otherwise indicated. Or this detail to S321, showing a section cut at the brick side of the wall with these 6 by 6 by 3/8 inch galvanized steel angles engineered to support the brick ledge. And here is the roof framing plan using steel beams and bar joists. Section 7 S321 shows how a bar joist frames into a steel beam. On sheet S403 are additional structural steel details and the office column schedule. Here, the engineer uses column marks 01 through 07 to identify the type of column, and in the box below references each column line intersection for additional location clarification. Opportunities as an engineer. There are two engineering disciplines that specialize in construction work: civil engineering and structural engineering. Civil engineering is one of the oldest engineering disciplines. Civil engineers plan and design large projects such as roadways, bridges, canals, dams, and wastewater treatment plants. Structural engineering is a subdiscipline of civil engineering. Structural engineers are responsible for determining the physical components that hold up the structure. Basically speaking, they analyze the loads and the forces. Becoming an engineer requires earning a bachelor's and sometimes a master's degree, then gaining professional experience and passing a state licensing exam. Engineers have many opportunities in the workforce, typically engineering firms, government agencies, and contractors. Okay, time to test your knowledge. Pause here and review the material in Unit 11, then answer the questions on page 201. When complete, continue the video to see the answers. Repause the video and check your answers. Pause here and using the Delhi Garden Center drawings, answer the questions on pages 202 and 203. When complete, continue the video to see the answers. Repause the video and check your answers. This completes Unit 11.